Okay, so we've got to start our next video here. It is about rational exponents. Okay, that's and radicals. So you're gonna be seeing a lot of radicals, at least at first, with what we got to take care of. So step number one is to start this process, and then get the title up there. Okay, so here we go. Let's give it its name. Let's call it rational exponents. Rational rational exponents and radicals. I'm just going to put this little sign there to say and radicals. Okay, so now let's get going. Let me show you a bunch of different type of problems that you can be facing. And let's start with the fundamentals. First of all, the square root of 49. There we have a radical. Hopefully that looks a little familiar from the past. A radical. Square root of 49. My second one coming is the fifth root of 32. That's also radical, right? We won't always have just a square root. All right, so remember that I'm going to put it up here, way up here, that there's an invisible 2 in that whenever you see just as plain square root. Plain square root with nothing in it, there's an invisible 2. If I want to say cube root or fifth root, I have to say 3. I have to put a 3 in there or a 5 in there, like you see. So just to get the fundamentals about what a square root is and what a fifth root of 32 is, here's the answer to square root of 49. We've had it before, but let's get into it formally. It is 7. So why is that true? Because basically you're answering a riddle. What is a number that when you multiply it by itself, times itself, you get back to 49? In other words, two copies. Two copies times each other, two copies, that 2. I multiply it, I get to 49. What is that number that will get me, if I multiply it times itself, I'll get back to 49. That number is 7, and that's why the square root of 49 is 7. So that's the full explanation, pretty much, of what a square root is. Now, what about the fifth root? I need a number that when I multiply it 5 times each other, I get back to 32. So I'm telling you, I'm going to tell you right away what the answer is too, but let me prove it to you. If you take 2, 1 copy, 2 copy, 3 copies, 4, and then 5, and multiply them all, you will get back to 32. Let me show you that. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So there we have it. The number 2 is the fifth root of 32. The number 7 is the square root of 49. That's how it works. That's the principle behind it. Okay, now we got to see a bunch of examples, and along the way you'll see some new things here too. They're inescapable. For one, we're going to have to deal with, let's say you have a numerator and denominator inside a radical, 49 and 64. So that shouldn't be too daunting. That means take the square root of the numerator. This is the same thing as saying, what's the square root of 49 over what's the square root of 64, right? I can give that one big radical, and give it to both the top and the bottom. The square root of 49 is 7. The square root of 64 is 8, and that is the bottom line answer. Okay, let's move on to some more problems. Let me put up a few before I start explaining, and you might be able to do a couple by yourselves as we go. Let's try with the next thing I want up there is the square root of 16. It's not supposed to be a hard problem. You'll see why it's up there. I need to contrast it. Then what about the square root of negative 16? And then after that, the negative square root of 16. We go from there to a cube root, the cube root of 27. And finally, the cube root of negative 27. We'll probably do some more practice problems too, but there's some fundamental stuff that I've just put up there. Okay, here's the explanation. The square root of 16 is equal to 4 because 4 times 4 gets you back to 16. If later on we're going to get a little bit more complicated, the real truth is that the square root of 16 is 4, and there's another square root. It's also -4, because -4 times -4 gets you back to 16. But for the moment, I'm leaving it 4. But the true answer, really, I'm putting it in brackets over here, is that really there are two answers. There's two roots, 4 and -4. But I don't want to get complicated right now. Let's just leave it at 4 for the moment. Now, here's where there's a problem. The square root of -16, that's not working. What's a number that times itself you get back to -16? Nothing works. Let me do some scrap paper work and show you that nothing works. If I try 4, 4 times 4 is 16, not -16. If I try -4, then -4 times -4 is equal to 16 and not -16. It's not working. So this is going to turn into something called an imaginary number or a complex number. I don't even want to discuss it at length. I'll tell you why I don't want to discuss it right now, because it comes up in about four or five lessons from now. We're going to have to deal with complex numbers. But I just wanted to expose you to it right now to show you that don't get mixed up. You might have on a test square root of 16, and if they give you a trick question, square root of -16, then right now we don't know how to answer that question. By the time you get the test, you should be able to, we probably have covered it, and you'll be able to answer the question. But that is, we know how to do this now, and we know that there's a negative inside the radical, then it's a complex number. Cn is a complex number. I don't want to spell it out right now because we're going to have to discuss it and study it later. Now, I need all three of these, 4, 5, and 6, up on the board at the same time. Because what's the square root of 16? There's no negative inside here, so I know what the square root of 16 is. Square root of 16 is 4. What about the negative? The negative doesn't go away, so the answer to this is -4. So we can answer problem number 4. We can answer problem number 6, but when the negative is inside, then we have a problem. That's a topic to be studied later in a couple of weeks, complex numbers. Okay, now, here are two more questions that are very, very important and very connected to what we're doing. What is the cube root of 27? So here's the riddle. What's a number? Times itself, 3 copies, gets you back to 27. The answer is 3. 3 times 3 is 9, and 9 times 3 is 27. So there's a very good simple answer to problem number 7. Now, cube root of -27. There's a negative inside. Does that mean we can't answer the question? No. Let me explain. The answer is -3. The answer is -3. Let me prove it to you. -3 times -3 times -3. -3 times -3 is 9, and 9 times -3 is -27. It works. So what's the difference between 5 and 8? Here's the difference. If there's a little 2 in there, right, the invisible 2, which I'm putting in right now, that invisible 2, if it's an even radical, right, if it's an even root radical, these are roots, square root, third root, fifth root, fourth root, third root. If it's an even number in there, then I cannot take the radical of a negative number inside. If it is an odd root, 3, right, 1, 3, 5, 7, 9, if it is 2, 4, 6, 8, 10, 12, no. If it is 3, 5, 7, 9, an odd root, then I can take the root of a negative number without any problem whatsoever. It's not a complex number. That's the difference. Let's practice what I just said. Let me show you that a little more, conserving all the space we can lay our hands on. Let me go over here to number 9. I want to show you that a little bit more at length here. 4th root of 16. We can take the 4th root of 16. I can show you in a second. Let me put a couple problems on the board. What about the 4th root of, sorry about that, 4th root of -16. That's number 10. Number 11. The 5th root of 32. Number 12. The 5th root of -32. So let me show you with these 4 examples and continue what we were just talking about. The fourth root of 16 is 2 because you do 4 copies of 2 right next to each other, multiply them all, you'll get back to 16. The fourth root of negative 16, complex number. Forget it, not our topic yet. Fourth root of negative 16, can't handle it yet. Why? Because the negative's inside, and that is an even root. Fifth root of 32 is 2. 5 copies of 2 multiplied by each other, you get back to 32. We did that right over here when we did problem number 2. Problem number 2, we did exactly this problem. What about the fifth root of negative 32? There is an answer. The answer is negative 2 because it is an odd root, 5, and it's got a negative inside. We are not daunted by that negative. That's fine, no problem, because this is an odd number. If it is an even number, then we can't do the normal root of a negative number. But if it's an odd root, then we can get the root of a negative number without any problem. It's not an imaginary number. It's not a complex number. It's totally fair game to ask this question now and to ask it on the homework. It's not premature. To ask this question is premature. To ask this question over here is premature. Okay, let's continue with some more examples of radicals. What if you've got as follows? The square root of x squared. We're no longer dealing with just numbers now. Remember that there's an invisible 2 here. The square root of x squared. And x times x, that will get you back to x squared. Answer, x itself. I'll show it to you right over here. I need all the paper I can get. Scrap paper. X times x is, there's a 1 here and a 1 here. 1 plus 1 is 2, is equal to x squared. There's an invisible 1 and an invisible 1. We never see them, but there they are now. 1 plus 1 is 2, x squared. So the square root, what's something that multiplies by itself gets you back to x squared? What will solve the riddle? Something that when you multiply times itself will get back to x squared. The answer to that riddle is x. An easy way of thinking about it is the invisible 2 over here. 2 divided by 2 is 1. X to the 1 and x are the same thing. Let's see some more with x's. What about the square root of x to the 4th? The square root of x to the 4th. And let me give you another one. What about the square root of x to the 32? The square root of x to the 32. There's another one. And finally, the cube root, finally for this series over here, the cube root of x to the 33. Okay, the square root of x to the 4th is an invisible 2 over here. What times itself will get you back to 4? Just divide it in half. Is an invisible 2, 4 divided by 2, x squared. What about x to the 32? What times itself will get you back to x 32? There's an invisible 2 over here. 32 divided by 2 is 16. X to the 16th times x to the 16th is x to the 32. What is the cube root? Sorry about that. Let's get rid of that. What is the cube root of x to the 33? Take the 33 and divide it by 3. You get x to the 11. And that is the final answer for this. Sorry about these little problems with my pen here. X to the 33, a cube root of that is to simply divide by 3, and you get x to the 11. Okay, so we're going to stop this video here. We have not finished this topic at all. We got to continue in the next video about rational exponents and radicals, but we'll stop here. We're running out of time.